Welcome back to the Tech Talks Daily Podcast, a place where we demystify complex technologies every day and provide real-world examples of how technology is transforming businesses and reshaping entire industries. But we do all this in a language that everyone can understand. Now, we have all heard the phrase, hey, not your keys, not your coins. And many of you will have your crypto coins in something like Meta Wallet and feel safe and secure as a result. But this year, the Solana security issue once again proved how if you introduce trusted intermediaries, they will get hacked. And rather than live up to the trust that we're all promised, bridge technology has been plundered by cyber criminals in the last 6 months. And MetaMask-style wallets are hosted on a cloud, like the Google Chrome store, for example, and they're updated by trusted intermediaries rather than algorithms and interact with the cloud. So what all that means, essentially, is that bridges are vulnerable to hacks. So today, I want to explore the consequence of people using centralized technology in blockchain and pretending that it's real crypto. And also explore how continued hacks of this nature should actually inspire people to focus more on internet identity, chain key cryptography, and generating alternative offerings to bridges. So it's a pretty big topic, and I've found the perfect guest to talk about this with. And his name is Dominic Williams from the DFINITY Foundation. He was last on this podcast, I think something like 5 years ago, so I think we're long overdue a catch-up. So buckle up and hold on tight as I beam your ears all the way to Zurich in Switzerland, where Dominic is waiting to join the conversation. So a massive warm welcome back to the show. Can you tell the listeners a little about who you are and what you do?
Well, thanks, Neil. It's good to be back. It's been 5 years, as I recall. I'm doing the same thing. I'm pleased to tell you I'm still working at DFINITY. The difference is that, we launched the Internet Computer May 2021. So as we speak, we're 18 months into mainnet being in production. It hasn't gone down once. And, there's a big growth in developer numbers. We've got thousands of people building on it. So we must have done something right all those years we spent in R&D.
And as you just said there, it's been 5 years since we last spoke. We're going to have a lot of new listeners, and we'll have people listening inside the crypto space and outside. So for anyone just tuning in and hearing about DFINITY for the first time, can you just tell me a little bit more about what it is and the problems that you set out to solve all those years ago?
Well, DFINITY is the original name for the project that sort of began in 2015 to develop technology that can create a blockchain that can function as a world computer, a giant shared world computer, essentially an extension of the internet that allows people to build directly on the internet using smart contract technology. And, I started working under the banner DFINITY in 2015. The DFINITY Foundation was created at the end of 2016, October 2016. It ran a sort of public fundraiser, an ICO if you want. February 2017 is one of the first. Aimed to raise much money, but it was a lot then. And we scaled out the team, raised more money in 2018. And, today we have almost 300 people, most of them very specialized, PhDs. We employ a lot of famous computer science researchers, cryptographers, and engineers. We actually have the largest team of sort of well-known cryptographers in all of tech, bigger than the likes of Google and IBM. And we probably run the largest R&D operation in blockchain, certainly the largest long-running R&D operation in blockchain. As you might imagine, developing a blockchain that could function as a world computer and replace, eventually, the aim is to replace all of traditional IT, things like cloud computing services, databases, web servers, and so on, i.e., the objective is that everybody builds on the internet computer, on this giant shared world computer, and abandons legacy traditional IT. Developing essentially a public decentralized protocol that can create a world computer is an extremely complex task, and that's why it took so many years. There were more than 6 years between the inception of the project and the eventual launch of the production mainnet, May 21 last year.
You've been incredibly busy, and there's so much I want to talk to you about today. So just to set the scene for today's conversation, a bit more recently, can you tell me more about how the latest Solana security issue once again proves that if you introduce trusted intermediaries, they're going to get hacked, right?
Yeah. I think the Solana has actually lots of problems. I mean, I think it's, is it into double digits outages since it's been running? There was another one that lasted almost a day just recently. And that's one problem. And that results from they're developing a protocol that isn't really mathematically secure and proven, and creating a network that functions more like a decentralized or just distributed database than a blockchain that has, will periodically go wrong and has to be fixed by Solana Labs. That's one problem. And then, you've got other problems, such as the need to make copies of digital assets from Ethereum, say, using a bridge. So, for example, they had this bridge called the Wormhole ETH, and that got hacked, and $330 million worth of ETH was stolen. And that's part of a much broader pattern. I think the amount of crypto stolen from bridges is now measured in the several billions. So all of these are symptoms of systems that either aren't properly engineered, aren't mathematically secure, don't depend on cryptography for their security and liveness, or involve trusted intermediaries. So Solana's problem with outages comes from a protocol that isn't really mathematically sound, and they built something that's more akin to a decentralized database rather than a blockchain, and this thing goes wrong and needs to be sort of fixed by a central party. And then the problem with the bridge is that it involves a trusted intermediary. And actually there are a wide range of different bridge designs out there today. For those of your listeners that aren't familiar, a bridge is used to create a copy of an asset on a source blockchain on a destination blockchain, typically because the destination blockchain has some DeFi that wants to play with the asset. So, for example, there might be some ETH tokens on Ethereum, or some ERC20 tokens on Ethereum that some DeFi systems on Solana, say, want to play around with. And what people do is they sort of check those assets into the bridge, which acts as a custodian, and then they create a wrapped copy of those assets on the destination blockchain, such as Solana. And the problem, of course, is that you've entrusted an intermediary with those assets. And, lots of things can go wrong. The trusted intermediary might turn malicious. They might be using those assets for purposes you're not aware of. The trusted intermediary might have a malicious insider who wants to run off with them, or they can just, make a mistake and get hacked. And when that happens, of course, the source asset is lost and the wrapped asset doesn't have anything back in anymore. So in the end, if there isn't somebody who recollateralizes the bridge, the users can lose a lot of money. In the case of the Wormhole ETH hack, Jump Trading Crypto recollateralized the bridge and injected 300 million or something to fix the hole. But you can't rely on that kind of thing happening.
And obviously there will be people listening that think that rather than living up to the trust that everyone thought around bridge technology, it's actually been plundered by cyber criminals in the last 6 months alone, hasn't it? Can you expand on that and what people are thinking around this technology now?
Well, look, the basic principle that Satoshi Nakamoto introduced was that we must remove trusted intermediaries from the system in order that we can achieve total security and provide people with immutable guarantees and escape, derive, valuable properties like censorship resistance. But the blockchain ecosystem has expanded very, very rapidly in the last couple of years. And, a lot of these new blockchains have been in a rush to get their DeFi ecosystems moving because it adds a lot of value to their tokens. And in that rush, they've sought shortcuts. And one of the shortcuts has been the use of bridges. So, rather than develop advanced cryptography that allows them to allow smart contracts that they host to access tokens on other blockchains, they've just introduced variations on bridge technology, which involve, the bridge acting as a custodian on a source blockchain, such as Ethereum, where you've got all these ETH and ERC20 tokens, who then issue wrapped versions of those assets on the destination blockchain, such as Solana or Avalanche or Near. And so that the DeFi smart contracts on those blockchains can manipulate them. And it works, but there's always the risk that something goes wrong with this trusted intermediary. The aim in blockchain should always be to solve problems using mathematics, because a hacker can't make 2 + 2 = 5, right? And that's essentially why cryptography is important. It's a mathematical system, and it gives you hard guarantees about what can and cannot happen. Similarly, consensus math, which is a distributed computing science, is also important for similar reasons. Bridges aren't built using distributed computing math or cryptography. I mean, they involve those technologies, but they're not cryptographically secure, for example. There's a trusted party typically involved. And if that trusted party is compromised, then those assets that are held in custody can get lost. And that means there's nothing backing the wrapped version of the assets on the destination blockchain. And in the absence of someone recollateralizing the bridge, replacing what's been lost, then, of course, the users who swapped their real assets for the wrapped assets find the wrapped assets are worthless and they've lost everything. And B, where you've got, DeFi ecosystems that use those wrapped assets, you can get a systemic black swan event occurring. So imagine when the Wormhole ETH bridge was hacked, if Jump Trading Crypto hadn't recollateralized it, that would have resulted in all of the wrapped assets becoming worthless. Now, bear in mind that those wrapped assets are themselves, used in further DeFi systems. Sometimes they're deposited in order to borrow other tokens, right? They're used as collateral and put on deposit. So that would mean that DeFi smart contracts had lent assets that hadn't lost their value in return for assets that had lost their value. And so, as you might imagine, that would cause very serious systemic issues within those DeFi ecosystems. And that's why, of course, some of these big investors behind the Solana ecosystem stepped in this particular case. But it's no way to build a blockchain ecosystem. And that's why at the DFINITY Foundation, we've been developing this thing called ChainKey Crypto. ChainKey Crypto, in fact, already powers the internet computer. It's very fundamental innovation in the field, but we've been adapting it so that the internet computer can create transactions in other blockchains. And this means that if you write smart contract code on the internet computer, it can directly operate on ledgers and invoke smart contracts on other blockchains. So, for example, currently in beta, people are already using it. Internet computer smart contracts can create Bitcoin addresses, receive Bitcoin on those addresses, and send Bitcoin. And they do this directly via ChainKey Crypto. So essentially, the internet computer blockchain is actually creating signed Bitcoin transactions and submitting them to the Bitcoin network. And that means you can effectively create Bitcoin DeFi using the internet computer today. And that those DeFi smart contracts that you create on the internet computer that interoperate with Bitcoin actually move Bitcoin on the Bitcoin ledger. There's no bridge involved whatsoever. And that means the trusted intermediary has been removed and the system is completely secure. So one of the things we think we're going to see emerging over the next year is native Bitcoin DeFi built on the internet computer.
It's incredibly cool. And I think for people listening that are outside the DFINITY community, I think it's important to highlight how MetaMask-style wallets, for example, are hosted on a cloud and updated by trusted intermediaries rather than algorithms and interact with the cloud, etc. So for those kind of people that are still living in that kind of world, what does it ultimately mean for users listening, would you say?
I think there are lots of different kinds of people in blockchain today. There's people like me who are in it for the long term, who are pursuing a very singular vision of what the technology can provide. And, in our case, we've created and continue to contribute to a blockchain that can play the role of a world computer, where you can build anything using smart contracts and run it and it'll run completely from the blockchain itself. So you could build a mass market social network on the internet computer, and you wouldn't need any traditional IT. That's very different to a traditional blockchain, or a blockchain like Solana or Avalanche or Ethereum or Near, say, where when those communities say, "Hey, this Web3 service is built on blockchain," what they really mean is the Web3 service is built on traditional IT, such as Amazon Web Services, and the data stored in a database. There's a web server, serving the user experience to users, and then just occasionally the user will interact with their MetaMask wallet to move some tokens or buy an NFT or something like that. That's a very different kind of thing. So the internet computer is a complete compute platform. You can use it as an alternative to traditional IT. It's end-to-end blockchain. So, for example, smart contracts on the internet computer actually process HTTP requests and can serve interactive web experiences directly to end users. And it's, hundreds of thousands of times more efficient. So it's economically viable to store user data on the blockchain itself. So it's a different kind of thing. And, blockchain markets are really very divorced from what's really happening on the ground with respect to things like technology, team, and vision. They don't really bear any relation. You can look at blockchains like Tron, where the token seems to get stronger and stronger. But, really, it's a dead chain. There are no developers building on Tron. And it's just a sort of copy-paste of Ethereum. I think people will look for different things. But we just keep sort of, keep tracking on our target, which is really more technical than financial.
It's great to hear that. It's refreshing to hear that. And I suppose essentially what we're talking about here is the consequence of people using centralized technology in blockchain that's almost pretending that it's real crypto. So do you think these continued hacks of nature like this that we've talked about today should actually inspire people to focus on things like internet identity, chain key, cryptography, and generating alternative offerings to bridges? Because that seems to be the sensible option, right?
Yeah, as you mentioned, MetaMask is a Google Chrome extension that is served into browsers from the Google Chrome Web Store. If the folks at Google wanted, they could ban MetaMask. In fact, it's happened twice in the past, which would prevent new entrants to the Ethereum ecosystem gaining access to these Web3 services. They could also do the same, of course, to all the MetaMask derivatives that are used in other blockchains. In addition, a malicious party who works for Google could modify that code and steal huge amounts of crypto. So there are a lot of problems with that kind of architecture. Incidentally, the MetaMask wallet, once it's installed in your browser, also interacts with this thing called Infura, which is another cloud-based system that hosts Ethereum nodes. So the whole thing's super fragile. It can be censored, switched off by Google. It can be switched off by Amazon. And it's very vulnerable to hackers. And in fact, actually, there's something brewing at the moment. Hasn't quite reached the mainstream media, but there've been a lot of people with MetaMask wallets getting hacked. And it generally is wallets that haven't been used for some amount of time. And it looks like a hacker has control of a very large number of MetaMask wallets out there. And what they do is wait for a wallet to go, silent, not do anything, dormant, and then, they sweep what's there. And I guess their reasoning is that if the wallet's not in use, nobody will notice and it won't create such an uproar. But they've been doing that for a while. Yeah, I'll send you the link afterwards. There are a lot of problems with the MetaMask system. That's why we developed Internet Identity. Internet Identity allows you to create a session with a Web3 service running on the internet computer. And you do that using your device as a password. So all modern devices have these things called TPMs inside them. This is a special secure chip which can hold cryptographic key material inside, into which you can send things like a session that needs to be signed, but you can never get the key out. So it's impossible to steal the key. And you can't even steal this key. You can't even get hold of your own key, right? Even if you open up your laptop or phone and get the TPM chip, there's no way of getting the key out from inside. So we use that chip in conjunction with something called WebAuthn, which gives access to it. It's a new web standard in conjunction with chain key crypto. And this essentially means that you can authenticate to Web3 services using any one of your devices or control of any one of your devices as a kind of password. So for example, on my laptop, I might, use the fingerprint sensor, right? On my phone, I might use Face ID. And you can also use, built for purpose authentication devices like Ledger wallets and YubiKeys, whatever you want. I mean, people tend to, have one internet identity they use for social media and make that very easily accessible, Face ID on the phone, fingerprint sensor on the laptop, and so on. And then you might have another one for DeFi where you perhaps only keep it on, conveniently on one device and then have, built for purpose authentication devices like Ledger wallets as backup. But it's much more secure than MetaMask, obviously. It's very convenient because you can just use things like fingerprint sensor and Face ID. And we think it's, a replacement not only for, old school crypto wallets like MetaMask, but also, Google single sign-on, Facebook single sign-on, and usernames and passwords generally.
And if we do have anyone listening that wants to move away from those old school methods and very curious about DFINITY after listening to our conversation today, just to bring everything to life, do you have any use cases or examples of the kind of problems that you're solving with DFINITY and the different options available, just to help listeners understand the kind of value it could offer them?
Well, look, I mean, DFINITY Foundation, is a primary contributor currently to the Internet Computer blockchain. Internet Computer blockchain is a world computer and it is capable of supporting just about any kind of application, whether that's DeFi or mass market social media, entirely on chain. So, for example, I always hark back to this one, but it was a project I got going myself. There's a service called OpenChat. You can find it at oc.app, oc.app. And that is a messaging service, right? With on the way to 100,000 users. It's served into your browser. You authenticate using internet identity, typically your fingerprint in your laptop or something, right? Mm-hmm. And what's amazing about that service, which will blow the minds of anyone who's actually been involved with developing Web3 services, is that OpenChat is running entirely on chain. The smart contracts it's built with can process HTTP requests, so they're actually serving the interactive user experience into the browser directly. And there's some clever cryptography going on there to make sure it's secure. And they're also processing every individual chat message. So on the Internet Computer, finality for what we call update calls, which like very much like traditional transactions, is just over a second, which is actually too slow for chat, right? So, if you and I were interacting over OpenChat, if I typed a message and hit return, you wouldn't see it for just over a second. Which obviously is amazing. It's still an amazing feat. It shows how powerful the blockchain is. So what they do is they accelerate it with WebRTC. So it looks instantaneous, but the actual exchange of messages is happening at a slightly slower pace, but still very rapidly. And these smart contracts are not only processing and storing every single chat message, they're also doing it for media messages, right? So if somebody sends a photo or a video to the other person, that's also processed by a smart contract and stored in a smart contract. The system works incredibly well. Like they've got these, incredible group chats with thousands of users on them and things like that. So that shows how you can build like a mass market social media service on the Internet Computer. But of course, you can go much further on the Internet Computer. So at the moment, you can send ICP with chat messages, which is making it more like SocialFi, right? Because now your account on the chat service is really a crypto wallet too. And of course, I mentioned some of these chain key features that enable smart contracts on the Internet Computer to interact with other blockchains directly without a bridge. So soon you'll be able to you'll be able to store a very wide variety of crypto in your OpenChat messaging account and send that crypto with chat messages. Like, I could say, hey Neil, here's, 1,000 Satoshis or something like that. So that's cool. And then the other thing is that because this chat service, OpenChat, runs entirely on the blockchain, right? The Internet Computer is the only, world computer in existence capable of supporting this. That means that, it's built 100% from smart contracts running from the blockchain. That means it can be placed under the complete control of a community DAO, a decentralized autonomous organization, because DAOs can update other smart contracts, right?
Yeah.
But they can't update, stuff that's running on the cloud, right? So the next step, I won't go into the gory details, but there's a special kind of DAO called the service nervous system that's becoming available on the internet computer. And shortly, OpenChat will assign control to the DAO. The DAO will run a decentralization sale to distribute its governance tokens. And thereafter, OpenChat will truly be autonomous, run like a protocol under the control of a community of thousands and thousands of people. And at that point, I think you'll see some very aggressive and viral growth happening, because it'll start to airdrop governance tokens to users that refer other users, say, right? Or successfully run very popular group chats. It'll start to airdrop governance tokens to users who help with tasks like content moderation, perhaps on these popular group chats. So it'll be making users owners of the service they use and love. And it'll be making users part of the team that advocates for the service and helps with tasks like content moderation. So that's going to be a truly paradigm-changing event. And all this is about to happen on the internet computer right now. And it's possible because people can build anything on this world computer. They don't need traditional IT. They're able to build entire systems and services on the blockchain, place it under the control of a DAO. This is very different to, block services built with other blockchains. So when you hear someone saying, oh, it's built on Solana, built on Ethereum, built on Near, built on Avalanche, they actually mean something very, very different. What they mean is that the service is built typically on Amazon Web Services, right? They've got an Amazon Web Services account. That's where, and the data is stored in a database, and the web is served by a web server. And that's where, all the data is stored and the data processing really occurs. That's where the user experience comes from. And then occasionally, at key moments, the user will use their MetaMask wallet to transfer some tokens on the blockchain or buy an NFT or something like that. But as you can see, that's kind of a very different meaning. And I think it's actually a bit misleading, because, we've done some surveys of the public. We've done some surveys of journalists, developers just come into the space, the institutional investors, retail investors, and so on. And, it's near 100% that believe that built on blockchain XYZ means that the blockchain is functioning as some kind of end-to-end decentralized compute platform. But nothing can be further from the truth. The internet computer is the real deal. It's a real world computer, and you can build anything on it. And it's a replacement for all of the tech that exists in the world. And you can now build these incredibly interesting services like OpenChat so that they run entirely from the blockchain under the control of community DAOs. And that's the real Web3 vision in my book.
Wow, that is a powerful message. I've certainly learned a thing or two from that, and I suspect there'll be a lot of people listening will be paying close attention to that. And as someone that's creating so many different solutions to people's problems out there, I've got to ask, what keeps you up at night, and how do you keep your curiosity and open-mindedness alive to find these new solutions and not just get stuck in your ways too?
Look, I think one of the things you need as an engineering entrepreneur is optimism.
Yeah.
And that's also, can be a failing out of strength. I'll give you an example. I started building my first computer game. It was a massively multiplayer online game in 2009. And I originally thought it was going to take me 6 months. I didn't, launch it till early 2011, and it took 2 years. Okay. And that caused me a lot of problems. So that was, the downside of optimism. Upside was that, it did succeed, and it grew to some millions of users. Wow. So I certainly didn't think in 2015. I mean, look, I was working on ways, I was working on applied cryptography in 2014, working on ways to speed up blockchains and so on. I certainly didn't think in early 2015, when I set out on this path to build a world computer, that, we wouldn't even hit mainnet until 6 years later, May 2021. So I think the unescapable reality is that if you want to build something like a world computer, there's a huge amount of R&D involved. And what I saw, but perhaps underestimated, was that in order to develop something like this, you really would have to build build a very large R&D capability. And that took a long time. And building organizations is tough. Like we started out, in the early years after raising money, we hired Ben Lin, who's the L from BLS cryptography. And, most blockchains now want to find a way to leverage BLS cryptography. Ethereum 2 relies on it. We hired Andreas Rosberg, who's the co-inventor of WebAssembly. And of course, most blockchains want to use WebAssembly for their virtual machine eventually. But, that was just the beginning. In 2018, we hired Jan Kameny, she's our CTO, who's leading crypto research at IBM. And then, IBM's top cryptographers all followed him, came to DFINITY. And so it went on. But, building an organization capable of building the internet computer is a very challenging and exhausting task because, especially with this field and in R&D, you have to find ways of allowing, true, research to work with engineering. And the reason for that is blockchains, such as the world computer, the internet computer blockchain, are created by a protocol, you're not constructing a system. So that means essentially you're defining things mathematically. And, that thing that you can then implement that protocol, and then people, these nodes running that protocol will create in this case, blockchain or world computer. So that, there's been a lot of bumps in the road. Like I never anticipated that, scaling up an organization would be as tough as it was. And I think part of that was due to the field, and just the scale of the technical challenges involved, but we have achieved it. The other thing, I guess, that keeps me up, that doesn't really keep me up. It's just a lot of work. It doesn't keep me up because I'm worried about it. Although there are some very worrying moments, it keeps me up just because of the hours, And here I'm here in Zurich, for example, and we got a lot of folks in California, right? So there's a time difference. So, I went into the office yesterday morning. I cycle in usually, came back, had dinner, and before dinner had ended, I realized I was late for a meeting, ran back into this office, and then was going again for a few more hours before, finally getting to bed. So that's why I lose sleep. Not so much worry, but just the amount of work involved. We also, it's no secret, the internet computer is a very disruptive piece of technology. And I think there are a lot of blockchain projects out there that are very concerned that it might make them obsolete in some way. And that resulted in an incredible number of attacks on the DFINITY Foundation, me personally, the ecosystem. And they've been difficult to weather. Or I think, we're past most of them, and things are sort of, the wind is beginning to blow in our favor a bit. But there's an extraordinary story there that one day I wouldn't be surprised if it's made into a film or something. But if anyone's interested in getting a taste of it, you can hear about some of it on this website, cryptoleaks.info. And we've definitely been through a lot as a project, and we're keeping our fingers crossed that now with this crazy bull market and the hype and froth subsiding a bit, the industry will be a bit more rational, and the bad actors who do these kind of things will sort of leave the industry and let it return to its more idealistic roots,
Yeah, incredibly cool, and what an inspirational journey you've been on. And one of the aims of this podcast in every episode is to try and demystify complex technologies, increase adoption from, whether it be business leaders, decision makers, and businesses that want to build on these platforms, but also users and how they can get involved too. And yes, we've offered a great overview today, and I think we've done a great job of simplifying that message, but there will be a few loyal members of your community, I suspect, that's just listening to the whole episode, hoping for a teaser of what to expect in the future. And I'm sure you get this all the time, and you have to be careful what you say with people hanging on your every word. But is there anything you can share about what they can expect and what your big focus will be next year?
Well, right now we're actually in the midst of releasing some huge new features on the internet computer. So they include these extensions to the underlying chain key crypto in the protocols that allow smart contracts to directly interact with other blockchains. So essentially, you can build a fully decentralized front end on the internet computer for Ethereum DeFi. And someone demonstrated that last week. They created a fully decentralized front end for Uniswap on the internet computer. And that allowed you to authenticate using your fingerprint and then trade. right? And behind the scenes, this front end is interacting, which is served from the internet computer, is then interacting with internet computer smart contracts to create signed Ethereum transactions that then result in trades on Uniswap. So that's incredibly exciting because it shows the Ethereum DeFi community how they can fully decentralize their DeFi, get rid of their dependence on traditional IT, and even improve the user experience because there's no MetaMask in sight. Right? People are now using internet identity on Ethereum and initiating transactions using the fingerprint sensor or Face ID. So that's very exciting. It's all part of the same feature that, there's this native Bitcoin integration. So internet computer smart contracts can directly, create Bitcoin addresses, receive Bitcoin, send Bitcoin on the Bitcoin ledger. There's something called HTTPS outcalls. And this enables smart contracts to make HTTP calls through not just process incoming calls, but make outgoing HTTP calls that are conformed normalized through consensus, if you like. So you don't need oracles anymore. So someone just did a demonstration of a smart contract pulling price data down from Coinbase, and that price data is in fact requested by multiple nodes in the network. It's then normalized using the smart contract function locally, and then the normalized data is agreed through consensus. So one application of that obviously is getting rid of oracles, which are trusted intermediaries. For those that don't know, oracles are services that copy off-chain data onto the chain where it can be processed by smart contracts like Chainlink. On the internet computer, you don't always need that now. You can actually directly query, your smart contracts can securely directly query the source of the data. You can also, if you're in the enterprise space, for example, use that to integrate your smart contracts with your enterprise systems that are perhaps running on traditional IT. If you're in the Web3 space, you might use that feature to integrate your fully decentralized social media service with a centralized Web2 social media service, say. So those are, huge advances. The other one is service nervous system. It's this super advanced DAO that you can assign your Web3 service to, and it'll run, thereafter the DAO, the service nervous system DAO, has complete control over your service. And in order to decentralize control, it runs a decentralization sale where it sells governance tokens in exchange for ICP or soon Bitcoin and stuff like that. The proceeds are actually held by the DAO. They don't go to the developer, right? So it's not like an ICO. So we're hoping it's kind of ICO 2.0, regulatory compliant ICOs. The ICO holds the proceeds, and the developers who created the Web3 service in the first place, and maybe some of their investors, of course, get founder tokens. So they get an allotment of these governance tokens, but their voting power is handicapped to ensure that they're never in control of this DAO. So the community is in full control once you've made this. So we think this is going to be absolutely huge, because vast swathes of the world don't have access to venture capital. Like, we have a lot of people building in India, and currently, they're reliant on handouts from blockchain projects, and that only goes so far. It's very difficult for them to get VC and things like that. So the service nervous system DAO functionality is going to democratize access to the tech economy, enable a huge amount of new talent to get funded around the world, and build exciting Web3 services. And then beyond that, there's all kinds of big features. A lot of the big features are incredibly powerful, but, you can't see them. So, for example, we've got deterministic time slicing in the wings, which will improve concurrency. The internet computer can run smart contracts in parallel because it uses the actor model. A smart contract is just a bundle of WebAssembly and persistent memory pages. And the WebAssembly can only operate on those persistent memory pages inside the smart contract. And then the calls made to other smart contracts are asynchronous. So, the internet computer already runs smart contracts in parallel. Deterministic time slicing will improve the parallelism, but it will also allow for smart contract executions that span multiple blocks. So currently, when a smart contract function is invoked, its execution time can't exceed the total execution time allocated to the block, right? It'll get on Ethereum, the equivalent would be an out of gas exception, right? But deterministic time slicing will allow for smart contract invocations that span multiple blocks. So, on the internet computer, it's so efficient, it's already viable to upload a photograph, say, and have the smart contract store that. Well, with this, you'll be able to run long-running computations on that photograph, such as applying a tint. And that might even be possible now, but let's say you want to do video processing. That involves a lot of computation. In the future, it'll be possible to upload video to the Internet Computer blockchain and have the smart contract process that video. And the smart contract execution will involve or span multiple blocks. So these things are, going to be incredibly impactful because, the purpose of the Internet Computer is to replace traditional IT completely. And that's IT industry is a $5 trillion a year industry. Cloud is $500 billion a year industry. Of course, when you build on the Internet Computer, you're building with smart contracts. You don't need firewalls. Cybersecurity is a $172 billion a year industry. So we're trying to do really big things. And, we're trying to go all the way. Our ambition, to put things in perspective, is ensure that the Internet Computer is able to host systems and services with greater efficiency than traditional IT, which means that, if you build on the Internet Computer, you'll be emitting less CO2. So we've got big aims. We want to do big things to DFINITY Foundation. And there's a lot involved behind the scenes with very complex features like deterministic time slicing. But that's just a tiny slice of what we're doing.
Wow, that is a teaser and a half there, man. That's incredibly exciting. And before I let you go, I always like to have a little bit of fun with my guests. And if we've not upset anybody in your community, which I don't think we have, I'm going to ask you quite a divisive question now. And that is, can you leave a song for our Spotify playlist? And that song could be something that means something to you, inspires you, a soundtrack to your cycle to the office in the morning, maybe, whatever it is. All I ask is, what is that song and what is the reason for that choice?
Well, gosh, tricky. I mean, look, I love electronic music. Not surprising for someone like me and into tech and the way I am. And I've been to Burning Man a few times. So I love old house, from the end of the 80s, early 90s. But I also love ultra modern sort of deep house and electronica. So, for example, who would be? I don't have time to. When you're into that, you don't necessarily listen to a particular band.
Yes.
There's a lot of people producing this music, and you listen to DJs who distill it and mix it. Right? There's we call it an art car in Burning Man or a sound car called Mayan Warrior. Mayan, Mayan Warrior. And if you go to their playlist on Spotify, you'll hear some really, really good modern deep house. Old stuff, gosh, it's like I listen to, I don't necessarily know what I'm listening to. Papua New Guinea by Future Sound of London. How about that?
Oh, yes. What a tune.
That one?
Yeah, man. It's just not aged at all. It sounds as fresh as it did when it first came out. Amazing tune.
That's right. Yeah.
Okay, well, we'll add that to the Spotify playlist. And we've covered a lot of ground today. So anyone wanting to find out more information about DFINITY, maybe even join your community and find out a little bit more from them and watch a few videos, etc. What's the best starting point for everything?
Well, in the past, we haven't been so good at comms and online content, but it's getting so much better these days. The DFINITY Foundation has a website, definity.org. You can find out about the team members and things like that. If you want to find out about the Internet Computer, a great place to start is just internetcomputer.org. There's a dashboard at dashboard.internetcomputer.org. But internetcomputer.org has links to everything, including like wiki.internetcomputer.org and developer resources and things like that. So if you want to find out about the team and foundation itself, go to definity.org. If you want to find out about the Internet Computer, go to internetcomputer.org.
Well, I'm someone that's been following your journey from the very beginning, and just hearing your vision and mission for the future and transforming traditional IT is just absolutely phenomenal. So I'm going to continue to follow you. The only promise I will make you, though, is I'm not going to leave it 5 years till we speak again. So we'll have to get you back on next year, but just a big thank you.
It's a deal. Thanks for having me. All right.
So the aim of this podcast was always to demystify complex technologies, put it in a language that everyone can understand, to increase adoption and attract more people, more businesses. And for me, the big takeaway from this episode was to just talk about the possibilities of generating alternative offerings to bridges. And we've talked about a lot today and covered a lot of different topics. So I'd love to hear more about your thoughts. Maybe you've got a completely different opinion. That's cool. We encourage that on here too. So whatever your questions are, thoughts, experiences, alternative viewpoints, simply send them over to me, techblogwriter@outlook.com. We'll feature you on a future episode. You're welcome to come on here and talk about it too. And we'll keep this conversation going. So I hope you'll join me again tomorrow for another episode, but a big thank you for listening as always. And until next time, don't be a stranger.